Hello everybody, and welcome to the Poor Man's Chemist. In this video, we are going to be making scandium acetate, which is very similar to one of the salts that I use to do the rare earth chemical garden, scandium formate. We could do scandium formate, I just thought the acetate might be something a little different. We are going to be starting this from scandium oxide, which you can see right here. This stuff is kind of expensive. Scandium, as in like the element, is actually not all that rare. It's not super heavy or anything, so it's not all that rare in nature, but there are not a whole lot of processes that concentrate it. So, you know, there's probably scandium in the dirt that you're standing on, but nothing's really concentrating it, so it's kind of the same concentration everywhere, which isn't super high and is not practical to get it out of the ground. It's mostly used in like aircraft engines, I think, and other super alloys because it's very light and it's very strong, kind of like titanium, I think. Anyways, so what we have here is 2 grams of scandium oxide and a little bit of water. This stuff is super powdery, man. It's like dust, and it stuck to the sides of the beaker, so I had to rinse it down in there. Anywho, according to atomistry and everything else that I can find, this stuff should dissolve in hot hydrochloric acid. I seem to recall I had an issue with this before and it just would not completely dissolve. But I think my acid was also a little more dilute. It's been years since I've done this. I don't know. We're just going to add some concentrated HCl in here, because the first step that we're going to be doing is making scandium hydroxide. In order to do that, we've got to get the scandium oxide to dissolve in hydrochloric acid. After that, once it's dissolved, we will crash it out with aqueous sodium hydroxide as scandium hydroxide. Then we can dissolve that in a limiting amount of acetic acid, evaporate down the solution over a hot water bath. We don't want to get it too hot or else it will start breaking down into the oxide. So that won't really do much for us. If you do this, if you were to repeat, once you have the hydroxide, then add hydrochloric acid to it, just enough so that, you know, you react almost all of the hydroxide. That's one of the keys here, so you don't have excess acid in your solution you're trying to evaporate down. But anyway, if you did that and you tried to evaporate it down to the anhydrous salt, it would just break down into the oxide. That's the case with like all of these fucking simple salts, which is why it is very hard to get them anhydrous. With the sulfate, though, I believe this is not the case. At least it hasn't been the case for europium and terbium and thulium. Those I was able to dry at a moderately low temperature in an oven to the anhydrous compound, and I know it was anhydrous because it was fluorescent, so yeah. Anyway, so you have to be very gentle with this once you're evaporating it down, or else it'll all go tits up. And to get ahead of somebody, because I know someone is going to put in the comment section that you could say dissolve the hydroxide in hydrochloric acid and then evaporate it down, and you could add ammonium chloride to it and then heat it up, and that will take off the water and you will end up with your anhydrous halide. It is not nearly as simple as Wikipedia makes it sound. It takes copious, I think it's like 6 molar equivalents. It's like some ridiculously high amount of ammonium chloride, and then you've got to like just basically heat it up and sublime all that shit off and let it carry off the water, leaving you with the anhydrous salt. It is a long operation, a pain in the ass. It gets ammonium chloride all over everything. It's just not nearly as simple as the literature makes it sound like it would be. Anyway, so what we're going to do now is we are going to turn on our stirring. We're going to try to. Hello, stirring. Something is wrong with this fucking stir plate. Oh, well, yep. Something is wrong with it. The stirring ain't working. We've Got power, but no stirring. Glorious. That's wonderful. I have no idea what's wrong with that. Does the heat still work? Fucking A. It's always something, man. That's great. One fucking stirring hot plate was already too few. And now I have no stirring hot plate. Man, motherfucker. Alright, my emergency repair procedure worked. Which was picking it up and banging it against the bench a few times. And I'll bet you this thing is going to give up the ghost before too long. I don't know. Then again, I've had fucking these things start fucking up, and I give it a good whack, and then it'll keep working for months. That's funny. I can't believe that actually worked. Alright everybody, so here is our solution of scandium chloride. I filtered out a very tiny amount of scandium oxide that didn't react. I was actually quite pleased with how much of it went into solution. It was a real bitch before, but just heating it and letting it stir was the key. It dissolved about as quickly as gold does in aqua regia, about the same time frame. So, you know, let it go for like a half an hour, it'll go clear eventually. But anywho, so I filtered it off and I diluted it with some water, you know, because I had rinsings and everything. And we've got it on here now. I have warmed it up a little bit, and I am going to precipitate out the scandium as the carbonate. And that's because I have since learned, since I started this, that scandates are a thing. So far as I can tell, scandium hydroxide would be soluble in excess hydroxide, but I do not believe the same is true for the carbonate. We'll find out, won't we? So, this is going to be a long and tedious process of neutralizing all that fucking acid with sodium carbonate. Yay. I'm not going to film all of this. I'm just going to come back when it's done. Yeah, for some reason it goes real cloudy like that at first, and then there we go. When it was cold, it stayed kind of cloudy, and that's one of the reasons I wanted to heat it up. Probably nothing. Anywho, I will come back when this is done, and we have our scandium carbonate, and we're ready to filter that shit. Okay, people, so here is our scandium carbonate. It almost seemed a little gelatinous when I first precipitated it, and it kind of looks like it on the side there. But actually, these are particles. At least they seem to be. It's filtering very, very easily. I really thought this was going to be a bitch to filter, which is why I'm using gravity filtration and not vacuum. But apparently, this is going to be very easy to filter. Who knew? So I'm just going to filter this. I'm going to rinse the scandium carbonate well with water, and then I will transfer that shit to a beaker, and I will come back at that point because we'll be ready to move on. Okay, people. So I tried testing the filtrate with pH paper to make sure that it was indeed alkaline and I had precipitated out all of the scandium. But instead, the pH papers kind of just react with the scandium and turn brown. So it was impossible to tell. What I did was I made up a solution, an aqueous solution of sodium carbonate, and then I poured the filtrate into it. And sure enough, I did get a little bit of precipitate. So just make sure that you don't trust pH papers. I mean, if they start turning funky colors that aren't on the chart, something has happened and they're not working. In which case, you know, add a little bit extra just to make sure you're getting it all, because scandium is kind of expensive. Anyway, the rest of it has been filtering out beautifully, very easily. I am just going to filter this shit through that to make sure we get it all. And then, like I said, I'll transfer that into a beaker and we will start to dissolve this in hydrochloric acid. Okay, everybody, so here is our scandium carbonate. I have it suspended in a little bit of hot water. It was a screaming bitch trying to filter this shit because it just kept wanting to somehow, some way come through the filter paper. Like, it would be filtering clear for a couple minutes, and then all of a sudden the fucking thing would go cloudy again. It did this a couple of times, man, until I would refilter it through that same bed of shit. And it just kept doing it until finally, like the last one was like only very faintly cloudy. And I said, fuck it, we're going with what we got here. But I did soak the filter paper in water, and I added a few drops of HCl to it to dissolve it. And then I poured it into here because I have decided that I want to do the chloride and not the acetate, because I'm very intrigued now by this notion that I might be able to create some kind of scandium chloride complex. So yeah, we're going to go with a change attack here. I may have actually mixed up chloride and acetate earlier, and if I did, I'm sorry. I had this idea like kind of bouncing around my mind over the last couple days as I've been learning more and more about this element, talking to you guys. And besides, you honestly expect me to remember what the fuck I said 2 days ago? Jesus Christ. So, here we go. We are going to very carefully, a couple drops at a time, because there's not much carbonate in here, add a little bit of HCl after our camera refocuses. God damn it. What the fuck is wrong with you, piece of shit? I guess we have piece of shit 3.0 here. Fucking piece of shit camera. Alright. I'm going to let this stir for a couple minutes. Make sure that it's nice and warm. I'm going to let it warm up just a little bit more than that. Because again, we do not want to go over with the HCl. If we do, then I strongly suspect it will form a chloride complex with the scandium, and that might be what that fucking yellow color is that I always seem to see when I dissolve this shit in HCl. That would answer a lot of questions. So yeah, we definitely don't want to go overboard with that. Slow and steady is the way to go here. Besides, even if you're not worried about it forming a complex, let's just say you're working like a regular old lanthanide and you don't have to worry about that shit with this particular, set of reagents, you don't want to end up with some god-awful acid salt that basically is your salt coordinated with a molecule of HCl or H2SO4 or some whatever other acid you're working with, because those kinds of things tend to be extremely hygroscopic. Of course, they have a rock bottom pH when dissolved in water, and they are generally just a massive pain in the fucking ass, which is why the base, the alkali, or carbonate in this case, there has to be a little bit of it left when it's all said and done, so that we know that the acid was not in excess. Very important. So I am going to go through this long process, and then I will come back when we are done with that part. Okay, people, I am sorry for the glare, but it's early in the morning because I'd really like to get this done and get this video out today. What we have here is our filtered solution of scandium chloride. Are we focused here? Piece of shit. All right. So you see, very nice. It's ever so slightly cloudy. This stuff got to a point to where I would add in a few drops of acid. I would let it stir for a while, and the cloudiness just was not changing significantly. Not wanting to go overboard, I stopped there because, again, I can't check the fucking pH because the pH paper reacts with it, and I just kind of got to eyeball it. Okay, acorns of death, awesome. So what I did was I just gravity filtered it overnight. See here, just threw some rolled up paper towel, and I mean, it was able to clear out the overwhelming majority of whatever these little particulates are. I'm not exactly sure why it is so persistently cloudy. It keeps putting me in mind of aluminum, and aluminum's kind of a bitch. I hate working with aluminum. Anywho, what we are going to do now is we are just going to evaporate this over the boiling water bath. I have to use my 500. I don't have another 100 ml evaporating dish. My last one broke. I got to get one. So we are just going to evaporate this down over boiling water until we get a nice dry solid. What I want to do is I want to take some of that, weigh it, dissolve it in water, and then combine it with a stoichiometric amount of cesium chloride, 3 molar equivalents of cesium chloride for every 1 molar equivalent of scandium trichloride. And that should give us cesium hexachloroscandate 3, which, according to a paper that I found this morning, is indeed a thing. Since this is a more recent paper, not some super old one, of course, they don't bother to tell you what it fucking looks like, and I didn't really want to look it up. So, I don't know if it will actually precipitate or not, or if we would have to evaporate down the solution in order to get the product. But, I mean, either way, starting this early in the day, it's like 9 o'clock, I should be able to get all of this done today and get the video out tonight. That is my goal. So, in service of that goal, let's get this party started. And need to rinse that. Okay. Rinse off the sides, because scandium is expensive. I do have more scandium formate, so I mean, I guess I could always get more scandium out of that, but that was kind of a pain in the butt to evaporate down and make, and I don't really want to lose it. Then again, I don't really have a use for it either. All right, so I will come back once this has evaporated down a good bit and we are ready to take a look at it. Okay, everyone, here it is. So what I did, I was evaporating it down, and as it was getting to where it was just starting to crystallize, I was about to film it, and then it turned into a kind of gummy mass. I wasn't real sure what to think. I mean, I know that stuff like this can do this, but I was very nervous that it was going to be breaking down. So I continued to evaporate off the water up to it reached a point of about being 90 degrees Fahrenheit. Then I was hoping a lot that if I just dried this out in the desiccator for a couple of hours, it would help the situation and turn this at least into a nice crunchy solid. This is not quite there yet. This is still just a little gummy, a little bit. It's almost like really, really stiff, dry putty or Play-Doh. It probably just needs a little while longer to dry out, and then it can be pulverized. You see it's starting to slowly turn white, which I imagine is good. That is the color it's supposed to be. And I'm going to go ahead and put the lid on this fucker because it's fairly hygroscopic. Now, to prove, as it were, the only proof I've really got, I am 100% confident as to what this is, right? There's no doubt in my mind that this is scandium trichloride hydrate. But if that claim is true, then this shit should be pretty damn soluble in water. And, as you will be able to see, it is. The residue that was on the bottom of the dish is already gone. Got a little chunk there that's being a little bit stubborn, and get your ass in solution. What the fuck is wrong with you? Don't make a goddamn liar out of me, you piece of shit. Okay, there we go. See? Absolutely, well, maybe you don't. Come on, piece of shit. You just don't like the fact that that's a white in one field, huh? Can we focus now? Yay. I don't know if it's showing up or not, since somebody wants to be a piece of shit, but there is no residue in here. I mean, it is dissolved cleanly to produce a transparent solution. And I will prove that shit as I pour it all over my hand. That's okay. It has a low toxicity. I'm fine. See? Very nice. So, I am 100% confident this is scandium trichloride hexahydrate. Now, I was going to turn this into the tricesium hexachloroscandate 3, but when I tried adding cesium chloride to a bit of the concentrated solution of the scandium trichloride, I didn't get a precipitate. I only just found out this morning that this compound can even exist, so I'm going to end the video here. I'm going to do a little bit more research, and then I am going to do a future video where we are going to do some hexachloroscandate salt, and we'll also make potassium scandate by dissolving scandium oxide into potassium hydroxide, because why not? And I mean, you know, that should give us a pretty good demonstration of this thing's transition metal character. Now, I ordered 2 grams of lutetium, and that is on the way. Type E Hapo, who has been a long-time subscriber of this channel and is a very skilled chemist, suggested that trirubidium hexachlorolanthanate 3 should be a thing, or might be a thing. I'm going to be doing some research in that as well. So anyway, I don't want to get down off into a tangent here, messing around with these. We'll wait for the lutetium to get here, and that way we can do the scandium, the lutetium, and everything in one video. And so the next video is going to be molybdenum pentachloride, because you guys seem to be kind of interested in these exotic chlorides. So until then, guys, sorry this video is all over the place with goals that were just changing every 5 minutes, but you know, hey, you guys know me and how I roll. If you like this video, give it a thumbs up, subscribe, comment, share the video, donate a few bucks if you are finding this interesting, because this shit is expensive. And until the next one, you guys, I will see you later. This has been very educational. I'm having a lot of fun with this shit.